Good evening, ladies and gentlemen, and it is very nice to welcome you all to the Scottish Centre this evening. And our talk tonight is a talk I'm really looking forward to for a number of reasons, and we have an excellent speaker as always tonight, which I'll introduce in a second. First to say, my name is Gary Johnston. I am chairman of the Scottish Centre, and it is my job tonight to introduce the speaker and to welcome you. Now, just the process of what's going to happen is that our speaker is going to speak for about 3/4 of an hour, could be slightly longer or slightly less. And there's going to be a whiteboard up on the right-hand side of your screen. And I would ask you if you have any questions to fill that in, or put your question on the whiteboard, please. And we will ask Andrew after his talk if he will answer the questions. We would like not to interrupt him during the process of his talk, partly because we're doing this on a virtual basis and we want to try and keep it as efficient as possible. It's nice to see the numbers that we have tonight, and it's so I would like to particularly welcome tonight Professor Andrew Millar, Chief Science Advisor for the Environment, Natural Resources and Agriculture for the Scottish Government. And in saying that, I would hand over to you, Andrew, and welcome. And I hope you enjoy your presentation as much as we're going to. Thank you.
Thank you very much indeed, Gary, and thank you. I hope you're now seeing some slides. Is that a... yes, we're seeing slides. Vicky, yes, thank you very much, folks. Okay, terrific. I can see the chat, but I won't normally look at it through the talk. So I was, really delighted to be invited to speak here. I'm by profession a biological scientist. I work at the University of Edinburgh, and I'm seconded 3 days a week to Scottish Government. So I think this is the first audience that I've ever used this opening slide for, who might actually know what this cloud formation is over a mountain valley very early one morning in the Andes. So if anybody who wants to clue me in, do so in the discussion. So for this talk, though, I'm speaking to you as Chief Scientific Advisor, as Gary introduced me. So a Chief Scientific Advisor has a number of different roles. So I thought I'd just lay that out a little bit for context. Number one, we champion the use of science in policymaking, in this case in Scottish Government. We're often involved in some form of strategic engagement. In my case, it's often between Scottish Government and the UK Government, and that's mostly involved in organising the advice and research processes. Scottish Government spends about £50 million a year on research for rural development, environmental sustainability, and agriculture. So I also advise on that research programme. And finally, Chief Scientific Advisors do give independent science advice to ministers and senior policy officials. And in my case, that can be on anything in the environment, in agriculture, or the rural economy. So that includes climate change, the subject of today's talk. And perhaps most relevant is that I was, in this role, I went to COP25 in Madrid a couple of years ago, and a couple of weeks ago to all of the COP26 summit in Glasgow, and I'm happy to take questions on any of those. Let's start. So tonight I'm going to talk about three topics. Firstly, about climate change, the global picture, and mitigating climate change. That whole agenda of getting the world and Scotland to net zero. I'll then talk a bit about COP26, the conference, the process, what happened, and then end by talking about adaptation, so the process of building a resilient Scotland, which is often a more local, more accessible activity than the rather forbidding, abstract, high-level net zero agenda. And I'll end with that because, in fact, extreme weather events are some of the really critical factors in climate change adaptation. So let's start off by putting the context from a natural scientist's perspective. That's where I am. This is a figure you'll probably know. It's called the Planetary Boundaries figure. It was developed by an international consortium, including Johan Rockström. And what it shows in these pie sectors is an impression of how much this particular feature of the environment has changed already relative to this solid dashed boundary, which is the definitely safe line. So sectors which are inside the bold line, we're thought to be in safe territory. And then this slightly harder to see dashed line, fainter dashed line, is the area which splits a zone of uncertainty in yellow from a zone of high risk in amber here at the edge. So this is, if you like, thought to be the threshold for a very high risk to the Earth system. Let's take the example my pointer's over at the moment. This is stratospheric ozone depletion. You may remember the Antarctic ozone hole some decades ago, addressed by a treaty to remove ozone depleting substances. Sadly, HCFCs are in the news again this morning, I noticed. So ozone depletion, thanks in part to that treaty and action since, is in the green zone, well within the safe boundary. Note at the bottom here, there are two sectors, or a split sector, labeled N for nitrogen and P for phosphorus, which are way over the safe threshold. This reflects the fact that about twice as much nitrogen is being fixed from the atmosphere by the Haber-Bosch process to make fertilizers and other things than would be fixed naturally. So this is a very severely impacted process. In contrast, most of the rest of the talk, I'm going to talk about climate change, the sector at the top. And you can see here, we're in the amber zone. Next to it, the other sector, which is well into, sorry, here we're in yellow. The sector that's well into amber is labeled here Biosphere Integrity, but often better known as biodiversity. So the state of nature, like the nitrogen cycle, the state of nature is at very high risk already, at least in terms of the species diversity. We are losing species and we're losing the diversity within species at an alarming rate. So you know the headlines, I'm sure. Footprint analysis suggests we'd need 1.7 Earths to sustain global current demands on nature. If everybody lived as we do in Scotland, that estimate is about 3 Earths. And in order to tackle these risks to the planetary boundaries, there's a consensus that we require transformative economic and social change. So some of the particular actions that we'll come back to through the talk are really examples set in the context of this transformative change that's needed to address at a large scale these many risks from our current ways of living. Of course, as a scientist, you could criticize any one of these individual boundaries. How do you know the line is really there? How do you know we're really that close to it? Any one of those estimates can be challenged, but the overall picture really has a very broad consensus behind it. So the key point is that we may be here in the little city, and our current advice, most approximate, pressing advice is be sure to wash your hands, face coverings, space, because we're dealing with COVID-19, but behind COVID-19, we have an economic recession, behind that climate change, and behind that collapse of nature. That's acknowledged at the very highest levels. So the UN-sponsored processes to assess all of that scientific consensus on nature is a process known as IPBES. And on climate change, the equivalent international scientific process is organized by the IPCC, the Intergovernmental Panel on Climate Change. Those two bodies released a joint report earlier this year, which is making essentially the same point as the cartoon. And therefore, you'll very often hear in Scottish policymaking this phrase, the twin crises. So I'm talking now about climate change, but to make this point, I just want to spend one slide talking about biodiversity. So the nature and the climate crisis are very intimately linked. If we're going to address either of them, we really have to address both of them. So why is that? Well, functioning ecosystems are a critical part of dealing with climate change. Climate change arises because we have too many greenhouse gases in the atmosphere, but those gases are in a process of exchange between the Earth system and the biosphere, everything that's living, and the atmosphere. It's only in the atmosphere that they're causing warming. So the oceans are taking in CO2, photosynthetic organisms in the oceans are fixing it, just like forests are on land. If those ecosystems don't function so well, the amount of greenhouse gas they take in is reduced. And how do those ecosystems function well? Well, they function well when they are biodiverse. That's what this middle graph is showing. If biodiversity goes down on this axis, then ecosystem function in general is reduced. It then becomes less stable, less resilient to shocks. What sort of shocks? Well, one of the big shocks is climate change. Climate change is directly affecting biodiversity and affecting ecosystem function in other ways. So these systems which are helping to mitigate climate change, to suppress those greenhouse gases in the atmosphere, they are themselves under threat. What can we do about it? This is a graph that is being used really commonly now. It comes from a Nature article led by the World Wildlife Fund, and the title of the article is Bending the Curve on Biodiversity, which is a really nice image. The image works like this. The black line is history. Our biodiversity is in some generalized index going down and down and down and down, and here was 2010, roughly where we are. At this point, we have three conceptually different pathways into the future. We can keep on doing what we're doing at the moment, which is not nothing. We are working on conservation, but not enough to stop the decline, and we will continue down the grey path. Or we can maximize all of our conservation efforts and create many more protected areas and stabilize the system, but we'll stabilize it with even less than we have now. Or we can change both the conservation process and also the economy so that we make fewer demands on nature. Those two things together are required to bend the curve such that we begin to restore some of the biodiversity in this green pathway. So that idea that transformative change of the economy and society is required is common both to biodiversity and to climate change, even though for the rest of the talk, I'm really only going to talk about climate change. So let's go on to that. What is it? Where does it come from? Earlier this year, the IPCC released the first part of its mammoth sixth assessment report. These reports come out roughly every 5 years. They are a global scientific consensus. So SPM is the summary for policymakers. That's about 40 pages worth. Then there's a technical summary, about 150 pages, and then the main body of the report, which is hundreds of pages long. There are many authors involved, several from Scotland. So you can see the headline here. Human influence has warmed the climate at a rate that's unprecedented in the last 2,000 years. So there is 1 AD. Here we are now. You can see this very rapid warming since 1850, and the grey bar at the side compares, this is the range of estimated temperature for the warmest period in the last 100,000 years. The point being, we are now above the estimated range in the warmest, substantial, measurable interval of history in the last 100,000 years. And that is due to human activity, because if we simulate Earth without the human activity, we get the green line, which really has barely risen at all. This Working Group 1 report, the first part of the 6th assessment, goes on to use a set of scenarios to ask what happens next. And the basis of those scenarios is to say, okay, let's imagine that our economic activity, our policies, our nature combine to create a particular amount of emissions over time. And the different colors on this graph show you those different emissions scenarios. The light blue one is often called the very low emissions scenario. You can see it crosses the 0 line around 2050. And it's about, say, 40 gigatons a year of CO2 now. By 2030, or just after 2030, it's fallen to half that. So compared to a rising line, actually, at the moment, this is a very, very sharp change. Dark blue, low emissions, a little slower, but still net zero well before 2100. And then yellow, slower still, red, continue as you are, and dark red, accelerating emissions. The process then says, okay, if society did what we've shown on the graph, then what would the planet do? And that's shown on this graph. This is showing global mean surface temperature change. So 0 means no change since 1850. And then a collection of models is used, taking the greenhouse gas scenarios that we just looked at, and the process asks, what do we expect to happen to global temperature if we had that emission profile? Here's our very low scenario in the light blue. This one is compatible with the Paris Agreement of COP21. So the ambition of the Paris Agreement was to limit global warming to 1.5 degrees above the 1850 level, and by 2100. So the light blue does that. It's 1.5 degrees or below at 2100. However, even this very optimistic scenario overshoots 1.5 in the middle. There's a little low bump there. Low emissions also overshoots, but at least it stays below 2 degrees. And then the intermediate one is about 2.7, and continue as you are, 4 degrees. So these are not predictions. These are just saying, if the scenario happened, then this is what would happen. There are significant unknowns still associated with these models, but they are by far the best that we have. And they are useful because they're a scientific consensus. So the thing to remember is, as has been often said, 1.5 degrees of warming at 2100 is still possible, but it will require a very rapid change globally from now. So where are we? Here's Scotland. Scotland on the right, the maritime area, huge sea area, Scotland has. Really exciting plans for new marine protected areas in various different colours, different levels of protection. And on land here in the right-hand panel, this is a map of Scottish crops developed by my colleagues in RESAS and Scottish Government using satellite data combined with field boundaries to score what's inside each field. Everything that's green is fields of grass, so grazing. Everything that's in this beige color down the edge, I hope you can see, those are arable crops. And then in the gray, well, lots of woodland, moorland that isn't enclosed in field boundaries, rough grazing. A lot of this would be our peatlands, so maybe 20% more, I'll show you later, of Scottish land is covered in peat soil. It's really rich organic soil. We have 17% woodland cover, and that's already a change. So a couple of thousand years ago, it would have been very much more than that. But in 1900, that woodland cover was just 5%. So Scotland's land surface has already changed quite substantially. But we have just this rather narrow strip of good quality arable land around particularly down the east coast. That's where we are in space. What's happened to our emissions? What's our emissions story in time? Well, it looks really quite radically different than the emissions scenarios that I showed you before. Here we're looking at a baseline of 1990 total greenhouse gas emissions, and that's 100% at the beginning. And then we go from 1990 on the left up to 2050 on the right. Blue's what has happened already. We've come down below 50% of our 1990 emissions at this point. And then the various markers into the future are obviously targets and projections for the future. These are targets, they're not projections, sorry. And what I'm showing you here in the different colors are different sets of targets that have been used in the past. So the ones in gray here, which are called current, well, that was current in 2018 when we were aiming for a 90% reduction of greenhouse gases by 2050. In 2019, that was updated by a new Climate Change Act. So that's what gave us the net zero target in 2045. That's what our green line is aiming towards. But in the process, the Scottish Government chose not the 70% reduction by 2030 that Committee on Climate Change suggested as the linear pathway to net zero. Parliament chose a 75% reduction. So here in Scotland too, we are aiming to reduce our current greenhouse gas emissions by 50% by 2030. So that's exactly in line with that light blue scenario that I showed you on the global scale. This is, to quote the Scottish Government website, the toughest, most ambitious legislative framework on climate change in the world. Some of those words are quite important. So we have annual targets. If the government misses a target, it has to provide a catch-up plan, and so on and so forth. Okay, what does the future look like though? This is really simple. The future looks radically different from today. This is rather a complicated graph, but all of the 5 leftmost bars are just slight variations on each other. They're all very similar scenarios. And this is all about what happens in 2050 and which bit of the economy is still emitting. Basically, all of these ones say there's a bit of light green above the line and lots of dark green below the line. Light green is agriculture, dark green is forestry. So basically, the rest of the economy has just stopped emitting in these scenarios from the Committee on Climate Change's 6th carbon budget. This is their previous report. They show a big black component. This is engineered removal, so carbon capture and storage. That's still present in these scenarios. They just didn't happen to plot it on this graph. So we have green and a sizable chunk of carbon capture and storage, offsetting the last remaining emissions from agriculture and maybe a few other sectors by 2050. So this is a completely different world from what we have today. It's really hard to imagine how that society works, but that is indeed the Committee on Climate Change's task. So what Scottish Government is grappling with is how to get from where we are now, we've come down 50%, but all the sectors of the economy are still emitting, to something that looks a bit more like this, or looks very much like one of these. How do we do that? Well, this is the way that those emissions are split up across the economy. This is the same data I showed you before, starting in 1990. Instead of being everything added up into one line, we've just split up that line so we can see which part of the economy is emitting how much greenhouse gas. The grey line, which falls like a rocket, is the energy sector. So this is closing the coal-fired power stations. So there's just one fossil fuel powered power station left. The rapid spread of renewables. Transport, still emitting, one of the very highest sectors. And then the other major emitting sectors now, business, agriculture, housing. Down here, the minor sectors, you can see this green dots also fell very rapidly. That's lovely name, LULUCF, land use change and forestry. So it has peat, emitting, and forestry, sequestering, capturing carbon. And this is the government's challenge. We have this. We need to get to the scenarios that I showed you before, where essentially agriculture is all that's left above the line. A huge, huge challenge. And that's what this document addresses. This is the Climate Change Plan update from Scottish Government, released last year. It takes those same sectors that I had on graphs last time and projects an envelope of emissions for each sector forwards from 2020 in this column to 2032 on the right. I'm sorry that the numbers will be really small on your screens. I do apologize. I'm going to just highlight a couple of them as examples. I mentioned transport, really high emitting sector at the moment, 11 megatons of carbon dioxide equivalents emitted in 2020. That goes down to 6.5 by 2028 in this plan. So nearly half, reduced it by nearly half. Buildings, that means heating buildings largely in Scotland, from 8 megatons in 2020 to 2.5, a third of the previous amount by 2029. So really dramatic change. Agriculture from 7 to 5.5. So falls by about a third. Quite different levels of activity, different levels of ambition for the different sectors, reflecting their constraints. So I'd be really interested if you've seen any discussion about these numbers, which are on the very last page of this document. Have you seen discussion of them? Has you been aware of them? One you might have come across. If you have, just pop a note in the chat. Maybe we can talk about it later. One you might have been aware of is this line in blue. It's called RMetS, which stands for Negative Emissions Technologies. That's your carbon capture and storage again. It does nothing, and then suddenly by the end, by 2032, we need to have constructed enough negative emissions technologies to be capturing 5.5 megatons a year. In other words, all that agriculture is emitting. So another big engineering and policy challenge. What I want to stress is that that single table I showed you on the previous slide has essentially the whole economy on it. If you think about Scottish ministers, led by the First Minister, Nicola Sturgeon, these four are the ones who are most directly impacted by the environment portfolios. Mr. Matheson, Net Zero Energy and Transport, Ms. McCallan, Environment and Land Reform, Ms. Slater, who includes green skills, circular economy, and the biodiversity challenge. Ms. Goujon, whose portfolio includes rural affairs and islands. But those issues I showed you cross well beyond their portfolios across most of the cabinet. Most issues previously in government didn't do that, except for the budget. So this is a really new context for making policy, and to try and help the ministerial team we've just set up, the First Minister's Environmental Council, similar to a previous body which advised on economic policy. It's our impression now is that these environmental issues are so pressing on such a scale that you need advice on a really different level than has been provided before. And you need what in academic circles is called systems thinking, thinking about the whole of the country embedded in the global system. It's a really challenging process, a really challenging area. One of the areas where that's happened already is in environmental policy broadly, not just climate. And this is quite a useful little graphic that comes from Scottish Government's environment strategy. What it shows you in the inner ring are outcomes from just the environment strategy. So for example, over here, I'll read it, it'll be hard for you to do so. Our thriving sustainable economy conserves and grows our natural assets. So this is the idea of an economy that supports nature rather than extracting from nature. In the middle ring, that supports two of the objectives of Scotland's National Performance Framework. I'd also be really interested to know who's heard of the National Performance Framework and who's interacted with it up to now. It's a really useful process of getting away from GDP growth as the aim of government policy, but it has many different indicators, and they can be mapped in the outer ring to the United Nations Sustainable Development Goals. In terms of societal challenges, societal goals, the Sustainable Development Goals are the highest level, most internationally recognized. So this is one way of conceiving how Scottish Government policy in climate change, in biodiversity, is trying to address the outcomes of our whole society's functioning. And then how would you tell whether the government's doing a good job or not? Well, you need these indicators. You need something like a performance framework, which is great. It's fantastic that it's there. It's got lots of statistics behind it. It has 81 different indicators. It's really challenging to tell a compelling political story about an 81-dimensional object. Nonetheless, this is the way that we now need to start engaging people, engaging the public. And it may be that we need new forms of democracy to do that. I'm highlighting here Scotland's Climate Assembly, one of the processes of called Deliberative Democracy. It took over 100 people from across Scotland, gave them evidence and information, and then asked them to suggest policies, and it's come up with some really interesting ideas. I'm going to suggest next that groups like this, people like you, are really well placed to engage in processes like that. Maybe not at the national scale, but at the local scale for sure, because it's easier for you to get together the data and help others to use it. How do I mean? Well, here's an example. Again, in chat, have you ever heard of this? This is the front screen of a website from the UK Department of Business, Energy and Industrial Strategy. This is the school version of it. There's a more detailed, slightly more professional version of it, which is called the Makai Carbon Calculator, after the excellent late, much lamented David Makai, who was the chief scientific advisor at the predecessor department, DEC, who really championed the use of this calculator. So here, the school version makes it really clear. You've got these 40 levers, you've got this set of levers and more to tune the economy, the way that society works, and then behind the scenes, it will calculate how close you've got to your target, in this case, 35% reduction, or 80% reduction in the old policy, or net zero by 2050, and how much it cost. So you don't have to just deal with data. You can use a tool like this to put all of the different sectors together and run a scenario. I think these have a lot of promise, but there are very few of them available. So that was the global scale. If we want to make this real, we've got to have policies to actually achieve some of those falling envelopes that I showed you in the table. This is one of the pages from that climate change plan update with the things Scottish Government is proposing to do with concrete policies by these concrete dates. For example, by 2030, decarbonise the heating systems in 50% of Scotland's building stock, a really major target. Reduce car kilometres by 20%, so reducing demand for transport. One of those societal transformations that I mentioned. No concrete policy to achieve that as yet, but at least a target, an aspiration, a signal of the direction of travel. Funded very concrete commitments to expand programs that are already going. Planting new woods to capture carbon from the air, 18,000 hectares a year, whereas previously we've never done more than 11,000. 250,000 hectares more peatland to be restored over the time to 2030. These are very concrete things. They're in a class called nature-based solutions. So for the next little section, to make things a bit more concrete, less abstract, fewer graphs, I'd like to show you a bit of some of the work that's happening for this last line. Why do peatlands matter? Why are they a climate solution? Why is government investing £250 million in restoring peatlands? Well, Scotland has a history with peatland policy. During the 60s to the 80s, across the UK, peatlands were being drained and planted with woodlands. And this aerial photograph of the flow country shows you the results are there to this day. 670 square kilometres of the flow country was afforested, planted with trees, as a result of this a tax incentive that you'd now have to say was rather poorly designed. And since the 90s, there are large-scale projects to reverse this process because drained peat emits carbon. It loses the vegetable matter which has been condensed and compacted and soaked into the bog. When it's dry, the microbial activity releases all that to the atmosphere. There's twice as much carbon in our peatlands as there is in our forests. And so much of it has been drained. 80% of Scotland's peat is in really poor condition and is emitting as much as all of our forests are sequestering. The fastest way to stop this is to wet it again, so it stops emitting. And that's important partly because so much of it is degraded, and partly because Scotland has so much peat. I said 24%, more than 20% of Scotland. Well, this is new data from our colleagues in the Hutton Institute using satellite mapping again. The blue is areas of Scotland where we think the peat is more than 50 centimetres deep. So this new estimate suggests more than 30% of Scotland is covered in peat. So we have to deal with peat in Scotland. It is emitting just a huge amount of carbon. And we can contribute to those nationally determined contributions that countries have to put forward at the COP process by stopping those emissions. Scotland's been doing really well at that. My colleagues in Nature Scot run a program called Peatland Action. Since 2012, Peatland Action has been restoring peatland and re-wetting, blocking up the drains, getting the water levels up. So you can see here on the left, they started out really small. So £0.2 million, restored 270 hectares. Up to 2019-20, the last season before COVID, they spent nearly 10 million, restored 6,000 or a little more in a single year. So total to date, more than 30,000 hectares restored. Okay, we have 2.4 million. So a lot out there. And overall, they've spent about £30 million. So the government's commitment now we're going to invest £250 million over the next 10 years to 2030. That means restore 250,000 hectares in total over 10 years. So 25,000 hectares a year. Remember I said over the entire lifetime of this program, it's done 30,000. So now every year we have to restore nearly as much as the total of all past restoration. The Committee on Climate Change, remember I showed those 5 collection of bars with light green above the line and dark green below? That was their 6th carbon budget. Those bars include a target for Scotland to restore 60,000 hectares of peat a year, because this is such an effective way of stopping carbon emissions. So this target, it's not a Scottish Government target, it's our statutory advisor's target, is suggesting we should be restoring 10 times more peat per year than we've ever done in the past. So the only way of achieving that is by working together with landowners, with contractors, with the trainers who have to increase the capacity of this whole system. And this peatland work is just one example. In each sector of the economy that I mentioned, I could give you the same story about this radical need for transformation, transformative change. So let's move on to COP26 briefly. COP26 brought 20,000 people to Glasgow. It's a fantastic event. Several different worlds are all brought together in these COP conferences, the world of policymakers, the world of scientists, of activists, of civil society organizations. Lots of really useful work happens. But in the negotiating rooms, which are the business end of it, they work on these top issues, the nationally determined contributions. So you may have heard from the news, at the beginning of COP, the estimate was that we were on course for about 2.7 degrees of warming if those current policies had been enacted by 2100. The most optimistic scenario, if every country does everything that it promised and targeted, even if there were no policies to deliver it, is still not at 1.5 degrees, it's about 1.8. And in between the countries that have more concrete actions planned for 2030, if you take those, you get to 2.4 degrees of warming, targets which are intermediate in their degree of realism, according to Climate Action Tracker, about 2.1. So we are still not Paris compatible. We haven't got sufficient action globally to keep us at 1.5 degrees by 2100. However, this is significantly better than we've had in previous years. Real progress was also made on what's called the Paris Rulebook, that is the particular detailed regulations for accounting for these sorts of carbon markets and other things, carbon trading rules, as I mentioned. There was some improvement for adaptation finance, doubling of the amount offered to adapt to climate change in the future. There was no progress really, apart from an offer from Scotland, on loss and damage finance, that is help for countries that are already affected by climate change now. And then there were sectoral agreements, an agreement on deforestation, which is useful, a sort of coalition of the willing, not trying to get all the countries that sign up to these elements, but countries which are ready to do so, and then more can be added, a form of pressure. On methane reduction also, on technologies, and there was lots of work behind these headlines. So if we take the, these are the temperatures by 2100 that I mentioned on the slide before. This is what they call the ambition gap. This is the very low, like was a light blue pathway previously. This is that's what we need to do by 2030. And that's what our 2030 policies globally currently amount to. So Scotland really is one of the most ambitious nations because our 2030 target is here. What else happens? Well, lots of things that happen at COP are just about collaboration and learning, not for this year's target, but to help people in their next year's targets. And that can involve all sorts of different elements. And I was working on peatland because it matters so much for Scotland, but it also matters, it turns out, for Chile. Just as we have peat in the north, they have peat in the south. So in COP25 in Madrid, I ran a side event in the UK pavilion with the Chilean Environment Minister, then the President of COP, where we took a team of Scots, and here are Germans, and the Democratic Republic of Congo, and a Chilean climate champion speaking. We set up a series of work which ended in COP26 with Scotland and Chile signing a memorandum of understanding to collaborate on better peatland restoration using both their and our methods and experience. So that's much smaller scale, but it's concrete, it's real, and it helped Chile to include peatlands in their nationally determined contributions that they already announced. So mixed progress on the headlines, but really useful work behind the scenes. It's some of this is very abstract, some of it is very positive and friendly, and some of it really is heartbreaking. So this is a picture of the representative from the country of Palau in the final meeting, where countries are saying whether or not they're going to accept the draft text. The population of Palau is about 18,000, same as St Andrews or Peterhead. And what she said is, we're being flooded today. I don't want to go back to my children and tell them that I failed, various other things. We accept the text. So for small Pacific nations especially, climate change is very far from abstract. And the idea that you need to change what you do right now to adapt to climate change is critical. One of the other leaders says, our only hope is the life belt that you are holding in your hand. And that doesn't appear quite so immediate to us in Scotland, but climate change is nonetheless having a real impact right here, right now. This is the picture of the big fire out in the peatland in Moray in the spring of 2019. Much larger than fires we've seen previously, because the weather had been very different in the year before, and that's by no means unique. So in these slides that I've taken from the Climate Change Adaptation Programme, they note 10 warmest years on record since 1997. We're seeing already wetter weather, especially winters, and sea level is beginning to rise. Although summers are projected to be drier in Scotland in future, paradoxically, when the rain falls, it will more often be intense in limited heavy events, and that's inevitable because the warmer atmosphere can hold more moisture, and when it falls, we may, even if we don't get more of it will more of the available precipitation will occur in short, sharp bursts, and that's what raises the flooding risk. So if we look at the Committee on Climate Change summary from these UK Climate Projection 2018 data, this is a really useful set of projections down to 1 kilometre resolution, but they're quite hard to use for other than the professionals. So if we look at change by mid-century, average summer rainfall drier in Scotland, particularly under the highest levels of warming, sea level rise, winter rainfall significantly wetter. Many other countries, it must be said, are much worse affected than Scotland will be. But the effects will be real here, and for that reason, Scotland has had an approach to adaptation policy as well as to the mitigation policy, the net zero policy that I was talking about before. So the two things from this slide that I want to highlight are an organisation called Adaptation Scotland, which is the sort of focus for this work, but also regional partnerships and the leading one is maybe Climate Ready Clyde, for any of you on the Glasgow side. They've been very active in the run-up and during COP26 as a focus for information and action. And that's really part of my message here, is that mitigation has this very high-level process, but adaptation, getting ready to cope with climate change, is often quite local. It's about issues like flood risk. I'll show you this resource called Dynamic Coast to cope with coastal changes, erosion, and coastal flooding. Even the peatland is highlighted here as an adaptation action, because really good quality peatlands can help to smooth water flow. They can't absorb very much more water, but they can stop it running downstream quite so quickly. The Committee for Climate Change is the government's advisor on adaptation, as well as on net zero. It surveys the whole picture, many different possible risks, and assesses which ones are green, so there's sufficient action, no need to do anything more. Yellow could be a risk, needs more investigation, and this amber color, more action needed now. You can see how much amber we've got here. So these are very varied. So this one here is risks to infrastructure networks, like the rail network, from cascading failures, multiple connected failures, risks to infrastructure services from river and surface water flooding next to it, many others. Their top four, interestingly, these top four here, I won't go through them individually, they're all about nature. And these 8 on this slide are the 8 risks they think most need priority action in the next 2 years. So this is very immediate. But these are things which, you know, are substantially within control. So this one here is risks to people in the economy from climate-related failure of the power system. So not amenable to local people, but nonetheless a really concrete focused risk, and it's about good maintenance, increasing capacities. It's not about necessarily changing the way that we do things. A lot of these things are about good maintenance, preparedness for current weather, which then gives you resilience to future weather. How do you assess what you need to do where? Well, you need data, and you need tools like those calculators I showed before to assess where to use the data. So this is a really nice example. This is called Dynamic Coast. It's on the line at dynamiccoast.com, and it just shows where we expect high water to move inland in the future. Preston Pans has a whole area where that's going to be true. This is something you can look up online and use if you're in Preston Pans. One of the other areas particularly of interest to this group, weather forecasting is going to be just critical to adaptation. That was highlighted in National Rail's advisory task force that reported after the Carmont rail derailment, where there was a landslip, caused a derailment, and tragically 3 fatalities. Recommendation 1, use better weather forecasting inside Network Rail. But to do that, Network Rail needs to build professional competencies so staff can act as intelligent users of science. That's the critical thing about adaptation. Many groups locally need to be able to use the science and evidence which is out there. And to do that, they need tools like the calculators, like Dynamic Coast, and people who are informed, who can bring those tools to life, maybe like yourselves. In summary, I've said global warming is already here. We're at 1.1 degrees warming already. Scotland has very ambitious net zero targets, and some of the policies to address the particular sector envelopes I talked about, nature-based solutions, forestation and peatland restoration are some of those. Demand reduction is also going to be very important, like the car kilometre reduction target I mentioned. But those climate effects are already here in Scotland. We need to adapt to them. We need to adapt to them quickly, and some of that can be done at a local level. Those nature-based risks, which I highlighted on the CCC slide, they can be addressed in your local nature reserve. Understanding and communicating the data is an early step, and tools, particular online tools, can help in that process. That's really all I wanted to say. Sorry, I've gone a little longer than I expected. Thank you very much for listening.
Thank you very much, Andrew. That was absolutely fascinating. And
So that's a great question, David. And as in any accounting process, the details matter hugely. Scotland has always, or has for many years now, included a share appropriately, we think, its share of international aviation and shipping in our figures. They were one of the lines on the slide that I showed you, but it's one of the lines in the bottom cluster. And the big fall in Scottish emissions that came from the energy sector is nothing to do with consumer consumption of imported goods that exports emissions overseas. However, note that that inventory method has to be standardized so that it can be compared globally, and embodied emissions are not included in that inventory method. If you do include embodied emissions, then greenhouse gas emissions overall have not fallen nearly as much as you would expect, for the reason exactly that you say. However, the change in the energy sector is a really significant gain for Scotland, and that other nations around the world are still really trying to follow on. Yeah. I know it does look a bit that way. Actually, they are all falling. The two which fell quite sharply at the beginning were land use change, and forestry, and that's because a substantial amount of forestry came online, grew up to the point after a couple of decades when it was really starting to absorb a lot of carbon, and peatland restoration started, and so we're starting to limit those really bad emissions from peat. The other line that's falling relatively quickly is waste. So we're allowing less food waste to go to landfill, so that the methane emissions that produces are being reduced. And so, where you have separation of food waste, that's a really important thing to do, because it can then be composted or anaerobically digested, and not just go to landfill where it turns into methane, which is a very, very powerful greenhouse gas. Why aren't the other lines falling fast enough? Well, it's not just an individual's behavior, right? Individuals need to be in a system that allows them to choose good behaviors easily. So you have to have a well-functioning public transport system if you're going to reduce your passenger car kilometers, for example. So it's not at all just down to individuals. There's a really important role for businesses and for government to work to allow people to make sustainable choices. Mm. So that issue is often discussed in the context of carbon capture and storage. It's not the only case. The headline, I suppose, is that almost all the technology that we need for net zero, we already have. The issue is rolling it out at scale. So, for example, hydrogen buses apparently have been around for a while. They're just not used at scale. There isn't a hydrogen supply from sustainable sources at scale. We know how to do that. It can be done, but it needs to be done at scale. Many of these things need to be developed much more quickly and at much larger scales than they have now, than they have been so far. With regard to carbon capture and storage, several of the elements of that are already used. So pumping carbon dioxide down gas wells or down oil wells is already used as a method for extracting more oil. That's not why you'd be doing it if you were using that process for carbon capture and storage, and it isn't being done at the scale that's needed. However, UK government has belatedly funded pilots to develop carbon capture and storage. Unfortunately, they chose not to fund the pilot system in Scotland. So there's a risk now that Scottish carbon capture and storage, which we really need and which would provide some employment in the northeast, is going to be somewhat delayed by that, though we don't know exactly how much or what the impact of that decision will be in detail. They've retained the Scottish scheme on a sort of short list, so we'll see what that means.
Thank you, Andrew.
Yeah, so thank you. The figures that I've been giving are in megatons of CO2 equivalents. So the equivalence includes the calculation of gas lifetimes. So CO2 persists in the atmosphere for maybe 100 years or more, whereas some of the other gases are much more short-lived, such as methane. So the calculation of how much methane is equivalent to CO2 is a non-trivial calculation, but that's included, that its shorter lifetime in the atmosphere is included in that equivalence calculation. So in one case, in the first scenarios with the different colors, I used just CO2. In other cases, I was using CO2 equivalents, which included that factor that you raised. But that's a very sensible thing to ask about also. So on the first of those, politicians are definitely listening to scientists. We would always like them to listen more and take science into account even more. But obviously, it's just one of the inputs into the decision-making process. And certainly, I'm talking as a natural scientist, there's a lot of social science which needs to go to inform the policy development. And then policy development has other inputs, political inputs as well. So you never expect as a science advisor that science is going to be the only thing that determines policy. But remember, the whole issue, the whole area of climate change and biodiversity was originated by science. by the natural sciences. So it is very much a science-focused area. In the UK, we're very lucky, well, not lucky. Previous policy development has constructed the Committee on Climate Change. We're soon to have an office for the Committee of Climate Change in Scotland. They're committed to that. So that is, and I mentioned the First Minister's Environmental Council, which is more a policy body and isn't just climate change, it's the whole of the environmental space. The Scotland government has a really quite a substantial advisory structure to provide that input. I would never say that there are too many scientists inside government. It would be great if we had more scientifically qualified folk doing policy roles to make that absorptive capacity. So there's not just advice coming in, the way of using it is even better. That matters hugely. It matters as much as the advice. But yes, from my perspective, ministers are definitely listening. But remember what I said at the, about a third of the way through, they're faced with a system-wide change on a scale and at a speed that they have never seen before. No ministers have ever seen before. So that's why I stress democratic innovations like the deliberative citizens' assembly processes may be needed in order to change the mechanisms of government as well. It may not be enough to just use current government and science advice. As for COP26, I can very safely say we're much better with it than without it. It's reaching an agreement has to be done by consensus. I showed you the picture of the representative from Palau. In theory, any single country could stop agreement, yet agreement was reached. It's not perfect. It is terrific that countries have to come back in 1 year instead of 5 to increase their ambitions. That's a really important step. So it is what we have, the COP process, and it is much better than not having it. Is it everything that we would want? No, clearly not. But much better than not having it. And as I said, as well as the high-level work, lots of really useful mid-level work happens at the COPs. So anybody who has the opportunity to, get engaged in a future COP, not quite as easy, it won't be in Glasgow. Many observer organizations can accredit you to attend COP. And this year, there was lots more online attendance. So if you were accredited, you didn't have to be there in person. That's direct legacy from COVID. So I would really encourage people to go. It's fascinating.
it was
No, I was asking a very genuine question, but I couldn't tell you whether David Stevenson's Lee wave clouds or Jonathan's rotor wave clouds is the more likely, or whether in fact those are the same thing.
Yeah, an interesting one. Yes. Yeah. So are you you back at university in now, or are you still in the shadow of COP, summing up for the government just now?
Yeah, that's so exactly as you say. My appointment will end after Christmas,
Right.
so I have, I think, 8 working days left in Scottish government.
Right. Do you know who your predecessor or who's taking over from you?
Yes, yeah. So it's Professor Matthew Williams, from the School of Geosciences, also in this case from the University of Edinburgh.
All right, good.
Mm-hmm.
Okay.
So he is. You can ask him to come and speak about anything else in that broad remit that I mentioned. So biodiversity, ag, rural policy, and other aspects of climate change.
Yeah.
Equally.
It's going to be an ongoing debate for many years to come, and Vicky's question about are we expecting new technologies, I fully suspect that new technologies will come along which will not in itself sort the problem, but should have a dramatic impact on helping climate change.
I think one of the positive stories that people point to is the falling cost of renewable electricity. So from the cost of solar panels and the performance of wind turbines is falling very much faster than had been predicted previously. So maybe that can be replicated in other sectors, and for sure there are going to be technological innovations which will help, and some of those we can't anticipate. The point that I was making in response to Vicky is really you don't have to wait for them to plan for net zero. You do have to scale up radically technologies that we have now. Yeah. But you don't have to wait for it. You don't depend upon new technology, completely new technologies. Of course, by 2100, in a world that none of us can imagine very easily, there will be transformative technologies which will have developed since. But our job at the moment as advisors is not to imagine the world of 2100. It is to get us past 2030.
Yeah, it's just on the same theme. I remember it was when climate change first came about, it was actually an engineer who said to me, "Oh, I'm an engineer, trust us, we can sort this." And quite a bold statement, but I think there is something in that there will be technologies out there still to be advanced, maybe not discovered or created, but advanced, which again should help rather than solve.
I think, Gary, you're absolutely right. Advanced is a really good word.
Yeah.
Yep, really good word to summarize that.
Yeah. Well,
I mean, if you want to talk about other technologies, the whole of industry needs to decarbonize, and lots of industry at the moment is using fossil fuel or some derivative as its input. So you'll know the Grangemouth industrial cluster.
Absolutely.
That's all based on fossil carbon, and a lot of that is going to have to change onto alternative feedstocks. So we have a huge job to help refactor all of those industrial processes to use something that is probably biologically derived. It's plant matter where the plants have captured the carbon now, rather than using fossil carbon that plants captured or algae captured millions of years ago.
Yeah, I know Grangemouth very well. We've done quite a bit of work there. In fact, I'm off to stay in a Grange in a couple of weeks. I always think of going to look at the illuminations. It's quite a fascinating place. It's also a very scary place because if you go into the council office there, they've got the aerosols up on a board, a warning board above the desk, and it tells you what the 2.5 and the 10 particles are. It's quite frightening, to be honest.
Yep. So. No, absolutely. So, that's one of the other, potentially one of the other, among several gains of a 1.5 degree economy, is we should be looking for better air quality and reduced health risks from air pollution. We should be looking for better water quality, you'll be aware the Scottish Government has a really big focus on just transition, so a social process where industrial sectors do not wipe out whole communities of jobs. And so when I said that it's not just natural science that contributes to this, that's a very big part of it is just transition.
Yeah. Andrew, I don't want to take up much more of your time because I really appreciate, and the Scottish Centre appreciate your time tonight, but just one final one is, one of the concerns that I have, as we started off, I said to you that my main role in life is architecture and planning. And one of the things that we are seeing, which I think are false claims now coming in, a lot of companies are saying we're producing eco-friendly, we're producing carbon-free, we're producing whatever. And I know, because it's my business, that some of them are just factually incorrect. They're taking advantage to try and sell a product. Is that a big problem?
So that's an area of which is very active at the moment, and it's sort of summarized as agreeing standards for all sorts of sustainable versions of processes that we previously had, some of which were standardized, but the standards didn't include any sustainability angle. And that goes across the whole economy. It's, all sorts of different things. I think, building materials, absolutely not my area of expertise. They're yours, but I'm not at all surprised to hear that concern, because that's a concern that you definitely hear from other areas. At the moment, without standards, without regulation, it's free branding. Yeah. And that is not a sustainable situation. Consumers need to have confidence in, if they're going to be paying a premium price potentially, they need to have confidence in what they're getting for it. Even more so if you think about investors, and there are really very substantial investments being proposed for both afforestation, for peatland restoration, for a whole set of other climate-friendly opportunities. Those investors need confidence that they're investing in something that really is climate-friendly. And the standards to give them that confidence are only just developing. So it's an area that I'm sure, absolutely sure, is going to continue. I know British Standards Institute is working on it, but like I say, there are lots of different processes in lots of different sectors that all will need to be updated.
Andrew, we've taken up a lot of your time this evening.
I think that question actually was about, if that's okay, is about unintended consequences. So we're moving into new technologies. And I know through my work at CEPA that there's amines from the carbon capture, there's particulates from the tires, modern tires, and microplastics. As people move to electric and the heavier cars, stuff like that. And I just wonder if that's something that the Scottish Government are looking at.
So not just Scottish Government, but these really big changes. One of the concerns is that you try to do something at, as I was saying, at a scale and speed that hasn't been done before, and you run into an unintended consequence of a scale and at a speed that you hadn't seen before either. So it's a very challenging policy area. You can't not. Oh, I see. I'm still sharing. I didn't mean to do that. You can't do nothing. Right? You know what the timeline required for carbon reduction is, and yet you have a lot of unknowns. But that's not unique. Lots of policy is made under some degree of uncertainty, and our role as scientists is to try and assemble the best evidence, the best foresight, and bring it into the policy process.
I think some unknowns, though, maybe the knowledge was there, like diesels and the higher NOx emissions, and the information was there, and it was just kind of like, oh, we'll sort it out, don't worry about it, and it was never done.
So from your experience, then, what's the best way of addressing that risk?
I think
that good information isn't used.
I think it was just ignored, or there was too much belief the industry would sort it out. Oh well, the industry would know about it, but in 5-10 years time, we'll have a solution for that, and there never was, and then they cheated and got around it a different way. So
this is my argument, that more people need to see the data. The more people that see the data, the easier it is to see the data, the more different experiences, different angles, different perspectives you have on one of those problems, the more likely it is that somebody from some perspective is going to spot an issue that looks like it isn't being addressed, and then hopefully they have the time and motivation to ask the question.
Yeah. And sometimes I think politicians get caught up in the wrong thing as well, because I've been involved a little bit in the Edinburgh LEZ stuff, quite a lot actually, and it's got bogged down in carbon emissions, which actually there's not really a big. The LEZ doesn't affect carbon emissions that much, because a new car and an old car emit the same carbon. Really, it's all about NOx and reduction and stuff like that. And so, but the politicians have got really worked up on that, and it's holding back the progress on other things.
Yeah. So have any of you heard of this 2050 Pathways Calculator tool? Had you seen that before? No, I saw nobody in the chat said that they had. Dynamic Coast? Probably you'd heard of Dynamic Coast from SEPA.
I've heard of that, yeah.
Yeah. Because that's, okay, if you're not close to a coast, then it's not relevant for you. But I think those sorts of tools are, just terrific. That 2050 Pathways Calculator was designed for school group exercises. And there's a teacher book of how you take your class through getting to net zero, and just how difficult it is. I think it's really, that whole area, and SEPA has done terrific work on the flood risk warning system and making that really accessible and sending information through different channels, so you can always get your flood risk for your particular catchment, your particular river. Really helpful. I mean, you can see the way, apparently, the social scientists tell us, it has absolutely changed the way that communities use the data and the way that they address it. And then flooded communities who've had to work together do better the next time there's an environmental challenge, because they've worked together for some reason. They can do it again. It's but this is why groups like yours, groups like the Scottish Node Network Hub of the Meteorological Society, if you can just keep bringing forward some of those opportunities to use weather forecasting, use forecasting in general, and then help your members to engage with their local authority or their community group, wherever it is. I think this is what it's going to take. One of the things it's going to take. Anyway, thank you very much indeed for the discussion. Really enjoyed it.
Okay, thank you. And on behalf of the Scottish Centre, again, I would like to thank you for your time tonight. And we've taken up a lot of your time beyond the talk, so thank you very much for that. Thank you. And
mostly my fault for running over.
It was quite all right. Okay, thank you, and good night.
Bye.
Good night.